Hello grade 9s, welcome to today's Maths Lit video lesson. I hope you guys are well. Today we're going to be finishing off the section on representing data, and we've looked at the bar graph, the double bar graph, the histogram, and today we're going to be finishing off by looking at the pie chart and the line graph and broken line graph. So the pie chart is on page 280. And it's really simple. You could say it's easy as pie. And all we're doing is taking a circle, our pie, and cutting it up into slices. And the size of each slice is representative of the size of the data. So let's take a look at the first worked example. On page 280, I'll read the question. It says, a car salesman has to present the number of cars he has sold in the last week to his manager. He uses a pie chart to display the number of cars and the colors of the cars he has sold. So if you look at this picture, immediately you can see why pie charts are so useful. They're very visually clear as to the relative scale of the data. The proportions. So this pie chart shows us a number of things. It tells us the color of the vehicle and the percentage of the color sold. So we have this table here, and I'm just going to show you how we get the angle and percentage. The angle is, it gives the angle of the slice of the individual sectors, and the percentage is the percentage of each color sold as a proportion of the total. So the first thing we do is get the total number of vehicles sold for the week. So we've got 2 plus 1 is 3, plus 1 is 4, plus 2 is 6, plus 4 is 10 vehicles sold. So as a sector, each vehicle sold would be 1/10 of the pie. So the circle is made up of 360 degrees. So it goes like this, from 0 degrees to 180, and then from 180 another 180 to 360. So if there's 10 cars sold, and each car is 1/10 of the total, then the sector occupied by each car is going to be 1/10 of 360. So one car corresponds to 1/10 of 360, and that's going to be 36 degrees. Okay, so now we can find the angle for each of the colors. If there's 2 cars sold, it's going to be 2 times 36, which is 72 degrees. One red car, so one car is 36, one car is 36, 2 cars is 72, and 4 cars is going to be 4 sectors, so 4 slices. 4 times 36, which is 120, plus 24 is 144 degrees. Now, as a quick check, if you're not sure about the size of your sectors, you can add all these angles together and just double check you get back to 360 degrees. Okay, lastly we have percentage. So percentage can be calculated from the frequency. For the first color, we have 2 out of 10 times 100, and that should be 20%. Next we have 1 out of 10, which is 10%. 1 out of 10, 10%, 2 out of 10, same story as here, 20%, and 4 out of 10, we can do that on the side here, it's 4 out of 10 times 100, and that gives us 40%. Okay, remember when we're finding fractions, we find the proportion and just multiply it by 100. So the proportion is a fraction of the total, so that's why it's 4 out of 10, 2 out of 10, 1 out of 10. Okay, so the last one was 40%, and once again we can just double check and make sure the percentages add up to 100. So we've got 20 plus 10 is 40, plus 20 is 60, plus 40 gives us 100%. Okay, so now we're just going to plot this data on the pie chart. So to draw this, we need our maths kit, we need a protractor, and we need the compass to draw the circle. So once we've drawn our circle, I'll draw a radius like this, a line from the center to the edge. And now we're going to plot each of our sectors. So the first sector is 36 degrees. So on our protractor, we would look until we get to the 36 degrees. We'd place this protractor over the picture and we'd find the 36 degrees. There'd be a line like a ruler and we'd plot the first sector. Here what I've done is split the pie into 10 equal sectors, each of 36 degrees. So I would have moved my protractor from our starting radius, measured 36 degrees, moved the protractor to the next line, measured 36, and gone around the entire circle. So we said that one car represents 36 degrees. The first color blue is 2 cars, so it's 2 times 36 degrees, 72 degrees, and that's going to be 2 of these slices of 36. So I'm just going to rub out this line, and this entire piece is going to be 2 sectors blue, and that corresponds to 20%. Next we have red, which is 1 car, so it's 1 sector corresponding to 10%. Next we have white, which is also 1 car, also 10%. We have next black, which is 2 cars, 2 sectors, 20%. And lastly, we have grey, which corresponds to 4 sectors, and we get the full pie. Okay, so grey, 4 sectors, 4 tenths, 40%. Okay, and we're done. So these kind of pie charts are pretty useful. For example, the manager at this dealership might be looking at the sales figures for all the salesmen. Maybe there's a trend. Maybe there's just a lot of grey cars being sold. This could be compared by the regional manager for a number of car dealerships. And there could be a reason for this. For example, grey cars might just be cheaper. The color might not be so popular. And that might be why more cars are sold. Another factor is unrelated to this question is insurance. So certain cars with high visibility like red and white have lower insurance premiums because they are easier to see on the road and less likely to get involved in accidents. So that concludes this section. Next up, we're going to look at the broken line graph and scatter plot. So for the broken line graph, we've already seen an example of this in the assignment that was given out. It showed the number of jerseys sold, compared long sleeve jerseys with short sleeve jerseys. And basically, it's just a series of dots, and we join the dots with these line segments. and visually you can see if there are any trends occurring. So data points are joined by a line, and it can show trends for data which varies continuously. So in the test example, the number of jerseys sold changed month by month, and we were able to spot a trend for the long sleeve jerseys. We say that in Jan there were quite a few sold, or very few sold because it was hot, and then sales picked up and peaked around the winter season, July, and then sales started to drop again, going back to summer in December. So let's just take a look at this example in the textbook. This is on page 281. So here we are plotting temperature against each day of the week for a 7-day week. So we've got 7 dots, 1, 2, 3, 4, 5, 6, 7. And now that we've plotted the temperature for the particular day, so Monday was somewhere up here, Tuesday, Wednesday, Thursday was the highest temperature, and the lowest temperature is on Saturday. So it's Thursday, Friday, Saturday. So now that we've plotted these points, we're just going to join them with line segments. So we go like this. And can we spot any particular trend? No, not really. The weather does change very unpredictably. Very difficult to predict what's going to happen on a short-term basis. Like what's the weather going to be like tomorrow is anybody's guess. But a trend would usually persist for the seasons. Obviously, it would be lower in higher in summer, lower in winter. So next up, we're going to look at the scatter plot. So the theory on the scatter plot can be found on page 281. A scatter plot represents the relationship between two variables. So on our scatter plot, we'll have one of the variables plotted on the horizontal and the other on the vertical. So the plots are a series of dots. If there is some type of relationship, some type of pattern in the dots, then we say that the variables are correlated. So now let's look at the example at the bottom of page 281. So this scatter plot is comparing the two variables, maths and English marks. So the maths marks as a percentage are given on the horizontal axis, and the English marks as a percentage are given on the vertical axis. So let's look at this first point on the bottom right. It's telling us that this student got a 90 for maths and a 20 for English. So, each of the scale of this axis is 10, so it goes 10, 20, 30, 40, all the way up to 100, and the same story here, 10, 20, 30, 40, all the way up to 100. So if we count, we've got 9 dots for 90 for maths, and then 1, 2 gives us 20 for English. So let me plot a couple more. So the very first dot on the upper left shows us 10% for maths and 90% for English. So it's 10% for maths, 90% for English is somewhere up there. The next dot on the right hand side is giving us a 30 for maths and what looks like a 35 for English. So 30 for maths, 30, and then halfway between is 35. And I'm just going to plot the rest of the points. Okay, so I've plotted everything here, and we can kind of see a trend, a correlation between the points. It looks like students that do well at maths generally also do well at English. So you can see here a a 40 for maths and a 40 for English. So people that did badly at maths did badly at English. People who did better at maths also did better at English. So we've got like 60-60. And then people who did very well at maths also did very well at English. We've got a 90-95. So we can see this trend in the dots, except for these 2 points. So the points that contradict our trend are called outliers. So from this scatter plot, we may be able to pose a few questions, like based on the correlation, based on the trend. We might think that, okay, if you think of the subjects maths and English, English is a language, and with maths it's also kind of a language, a way to express ourselves in solving problems. So being good at one language would imply that you may be good at the other language. So that concludes today's video lesson and this section, and I've left a couple of problems for homework. Please once again ask if you're struggling, and I don't think there should be too many questions. I think the section is quite self-explanatory, but yeah, anyways, thanks for watching and take care.